Hello guys, so I would like us to look at multiplication in polar form. So when you're given your complex number, Z is equal to, let's say, R1 theta 1, and this is Z1, and Z2 is equal to R2 theta 2, and you're told to multiply Z1 times Z2, then multiplication is given by you multiplying the values of R, so that you have R1 times R2, and then basically adding the angles theta 1 plus theta 2. That's how you carry out multiplication. So for example, if I tell you Z is equal to 230 degrees, that's your Z1, and Z2 is equal to 340 degrees, and I tell you to multiply Z1 times Z2, then this is basically given by you multiplying the values of the R, so 2 times 3, and then adding the angles 30 degrees plus 40 degrees. So this will be 670 degrees. That's how you multiply in polar form. And if you're told to divide, division in polar form, this is basically given by, so if you have your Z1 is equal to R1 theta 1, and Z2 is equal to R2 theta 2, then Z1 divided by Z2 is the same as you dividing the values of the R and then subtracting the angles. So for example, if we have our Z1 is equal to 645 degrees and Z2 is equal to 315 degrees, then our Z1 divided by Z2 will simply be dividing the R's and then subtracting the angles. That's basically how you divide and multiply in polar. So this is 2 and then this is 30 degrees. So when you're given two complex numbers and you need to divide or multiply in polar, this is how you go about it. Now, the next, let's look at how to get powers of complex numbers. So this will basically take us to De Moivre's theorem. De Moivre's theorem. Now, if you have a complex number Z is equal to R theta, and you have, so let me call this Z1, and you have Z2 is equal to R2 theta 2. We've said that if you're multiplying these two, it's the same as R1 theta 1, okay, multiplied with R2 theta 2. That will simply give us R1, R2, and then theta 1 plus theta 2. Let's say you have R theta, you're multiplying it to another R theta. What will this give? This will obviously give us R squared, and then we will have 2 theta. Similarly, if we have R theta, and then another R theta. So this will give us R times R times R cubed, and then the value of theta plus theta, that will be 3 theta. So this basically simplifies to, if we have R theta and we are multiplying it n times, then this will be R raised to power n and then n theta. And this is basically the De Moivre's theorem. So basically, if you're told to evaluate the power of a complex number in polar, you just follow the De Moivre's theorem. So let's say you're given a complex number Z is equal to 230 degrees, and then you're being told to get Z cubed. So how do you go about getting Z cubed? You see, if you need to get cubed, you're going to take R, raise it to power 3. Basically, this is the same as, let's start from here. This is the same as taking the value of Z and raising to power 3. So we have Z raised to power 3, which is equal to 2 30 degrees raised to power 3. And this implies you take 2, you raise it to power 3, and then you take 3, you multiply by 30 degrees. So this basically gives 8 and then 90 degrees. That's basically how you go about the power. Now, this same de Moivre's theorem can be used to get the roots of complex numbers. So let's say you want to get the root of a complex number. So basically you're raising to power, but now in this case, you're just raising to the power of a fraction. So we've already established that if z is equal to r theta, then z raised to power n is equal to rn and then n theta. So for the root, basically we are looking for z raised to power 1 over n, and this will be equal to r raised to power 1 over n, and then 1 over n multiplied by theta. But now this is just the first root. If we are to get n roots, then what we need to know is that inside the Cartesian point, so we take the Cartesian as if it's a whole circle of 60 degrees. All the other roots need to be at equal distances. So if there are n roots, it means you will take 360 divided by n, and you will get the angle that make them be at equal distances. So if this is the first root, then the second root will be given by r1 over n, and then you will take the first angle that you got, 1 over n theta, plus this 360 over n. This is what will give us the second root. The third root will still be r1 over n, and then 1 over n theta plus 360 degrees over n plus another 360 degrees over n. This will be the third root. So that's how we go about it, and so on and so on. So let's take up an example and see how exactly that plays out. So let's say you're told to get, given a particular complex number, you're told to get the root. So let's take up an example, roots of complex numbers. So determine the square root of this particular complex number. So determine the square root of, so z is equal to 5 plus 12j, and then you're being told to get z raised to power a half. Now, note one thing, guys, this z is in Cartesian form. So the first thing is to first of all convert it to polar, because all this raising to power, we've been doing them in polar. De Moivre's theorem is given in polar. So we will first of all start by converting this to polar. Converting this to polar, we have to have a sketch and know in which quadrant this lies. So 5, x-axis positive, 12, so 5, 12. So it will obviously be in the first quadrant. How do we get the value of r? R is given by 5 squared plus 12 squared square roots. And this will give what? Our value of r will be 13. And theta is given by tan inverse of y over x. So in our case here, our y is 12 and our x is 5. So we have 12 over 5, and that will give us our angle theta as 67 degrees, 67 point something. So if we already have our theta as 67 and our r as 13, then it means z is equal to 13 and 67 degrees. So this is what we want to raise to power a half, or find the square root of. Now, as I've said, if we are going to raise this to power a half, then it also means we're also going to raise this to power a half, such that our first root will be equal to 13 raised to power a half, and then a half times 67 degrees. And that will basically give us, root 13, and the angle there, a half of 67.32. So that will be about 33 point something. So this will be root 13, and then our angle there will be a half of 67. A half of 67 is about 33 degrees. This will be our first root. Now, to get the second root, since there are only two roots, with an angle of 360 degrees, they are at equal distance, these two roots. So 360 divided by this will be equal to 180. So the next angle will be at 180 degrees from this first angle. So our second root will be equal to root 13, and the angle now will be 33 degrees plus 180 degrees. And this will give root 13, 180 plus 33 degrees. You can be able to get your answer of 180 plus 33 degrees. That will be about 3, 1. So 3, 2. So about 213 degrees for the other root. Okay, fine. Let's take up another example. Let's take up another example and see how exactly we can go about it. So let's say you're given a question like this. Let's say you're told Z is equal to 860 degrees, and then you're being told to get Z. So basically this is the cube root of Z. So you're supposed to have 3 numbers. Now the cube root of Z basically entails you taking the value of Z and raising it to power a third. And this gives the first root. Our first root will be 8 raised to power a third into a third times 60 degrees. 8 raised to power a third will give 2. A third times 60 degrees will give 20 degrees. To get the second third root, they are going to be at equal distances. And how many are they? 3. So the equal distance from each other of these 3 roots will be 120 degrees. So the second root will be equal to this 20 degrees flat at a distance of this. So this will be 140 degrees. And similarly, the third root will be at an equal distance from this other one. So that will be 140 degrees plus 120 degrees. And that will be 140 plus 120. So that will give 260 degrees. So basically, that's how we evaluate. That's how we evaluate the cube roots of particular numbers. Now, there are questions which come of this particular form. Let's say you're told to solve this particular equation. Most of the time, you'll not be told that you're looking for the cube root or something like that. So you're being told like z cubed minus 5 minus 12j is equal to 0. And then you're being asked to solve this. Now write it in a good way so that z cubed is the subject of the formula. We'll have z cubed is equal to 5 plus 12j. Okay, so after writing it like that, clearly you can see that this is a complex number. So, and in order for us to get the value of z cubed, we will have to raise it to power a third. Similarly, we do the same for this side, plus 12j to power a third. So we will have this and this will go so that z is equal to 5 plus 12j raised to power a third. Now raising to power, we have to convert this to polar form. So we will convert this to polar form first of all. After converting to polar form, then we can be able to find the cube root. So converting this to polar, obviously we know we have to do a sketch. 5, 12, this will obviously be on the positive side. So 5, 12, then we will have the value of our r, which is 5 squared plus 12 squared, square root. And then we will have the value of our theta, which is tan inverse of 12 over 5. Sawa sawa. So these values that we get here, we are going to have our z is equal to r theta, and this r theta is what we are going to raise to power a third. So we go ahead and find the first root, and then 360 degrees divided by 3 will give 120. So to get the second root, we add 120 onto the angle of the first root. And then to get the third root, we add 120 onto the angle of the second root. And that's it. That's it for this particular questions.